Problem 18. A rhombic dodecahedron is a solid with 12 congruent rhombus faces. At each vertex, 3 or 4 edges meet. Depending on the vertex, how many vertices have exactly 3 edges meet? Okay, so first of all, we know the number of faces. We know the number of faces is 12, right? And then we know the number of the number of edges. Well, let's imagine this is one face of our 3D dodecahedron, okay? Let's imagine this rhombus is one face of it. So you might think, well, one rhombus is 4 edges, right? And then we have our shape is made of 12 congruent rhombus faces. So isn't the total number of edges going to be 12 times 4? So isn't it just going to be 48? Well, it's not going to be 48, because if you imagine it in like a 3D way, for example, let this be like another face, and then let this be another face. Like, you can see basically every single edge of every rhombus is going to be used twice. Like this edge here, it's being used once. It's being used once by this rhombus here, this face, and it's also being used once by this face here. So every single side is being used, like every single edge is being used twice. So we need to divide this by 2 to find the actual total number of edges we have. So the actual total number of edges we have is going to be 24. Okay, well, how many vertices do we have? Well, here we can use a formula called Euler's formula for polyhedrons. So the formula states that the number of faces plus the number of vertices equals the number of edges plus 2. Okay, so we know we have 12 faces, and we know we have 24 edges plus 2. So our vertices is going to be equals to 26 minus 12 equals to 14. So we have 14 vertices in this shape, okay? Okay, now that we know how many faces, how many edges, how many vertices we have, we can actually set up systems of equation, and then we can solve for the answer. Okay, so let x be the number of vertices. Okay, let x be vertices with 3 edges, and let y be vertices with 4 edges. Okay? So we know that x plus y is equals to 14, right? The total number of vertices is 14. And then we can also get the 3x plus 4y is equals to 48. Because the total number of points is 48, because there are 12 rhombuses of 4 vertices. So now we just solve the system of equations. So x plus y is also equals to 3x plus 3y plus 42. And then we minus this equation, and we minus the equations, and we get y is equals to 6. So x is equals to 14 minus y, which is 8. And then we're asked for, and the question asks how many vertices that have exactly 3 edges meet. So the answer is going to be the value of x, and the value of x is 8. So our answer is choice D, 8.